5-number summary, box plots, and outliers. That's today's lesson. The objectives. The students will be able to find the first, second, and third quartile of a data set. The students will be able to find the interquartile range of a data set. The students will be able to represent a data set graphically using a box plot. The students will be able to compare and analyze box plots. The students will be able to calculate for outliers and graph them appropriately in a box plot. Some terminology. Fractals are numbers that partition or divide an ordered data set into equal parts. Quartiles is what we're focusing on today. The 3 quartiles, Q1, Q2, and Q3, approximately divided an ordered data set into 4 equal parts. About a quarter of the data fall on or below the first quartile, which is Q1. About half the data fall on or below the second quartile, which is Q2, also known as the median. About 3/4 of the data fall on or below the third quartile, Q3. Box and whisker plots. A way to organize data on a number line by organizing it into 4 sections. The minimum value is the smallest value. The lower quartile is the median of the lower half. Median is the middle value when you list them smallest to largest. Upper quartile is the median of the upper half, and maximum value is the largest value. Notice we have that on a box plot here shown for you. Quartiles, the 4 sections that make up the box plot. Each quartile represents 25% of the data. Notice though in the box plot that they are evenly spaced. That is not always the case. It'll have 25% of the data in each part, but some parts may be wider than others when the data is more spread out. 25%, another 25%, another 25%, and the last 25% of the data values are in those 4 sections. The interquartile range is the range between the upper and lower quartile. It's essentially the length of the box. Drawing box and whisker plots. The resting heart rates in beats per minute, BPM, of a group of people are given below. Find the 5-number summary, draw the box and whisker plots, then answer the questions that follow. There's your data. You need to list them in order. The lowest value is 50, that's our minimum, and we put a dot above the 50, not on the number line, but so you have enough space to complete the box plot. The highest value is 92, and you also put a point for that. The median is the middle value. There's an even number of data values, so it's right in the middle of 64 and 68, which is 66, and put a point for that as well. The lower quartile is the middle of that bottom half. So right in the middle of 58 and 60, which gives you 59. Put a point on your plot for that. The upper quartile is the middle of the upper half. So from the median to the highest value, we need the middle. It's between 72 and 76, which gives us 74. Put a point for that. We are going to do our whiskers on the outsides, put a line through our median, and then a box around Q1 to Q3. Now we're going to analyze a box plot from that last slide. It is drawn to the upper right, and the 5-number summary is given to the left. That might help us when we do our evaluations, our analysis. So what is the range? It's the difference between the highest and lowest values. 92 minus 50 is 42. Interquartile range is the difference between the upper quartile and the lower quartile. So Q3 minus Q1, which is 74 minus 59, or 15. What percent have a resting heart less than 66 BPM? So find 66. That is 2 of those sections, so that's 50%. 66 is our median, so it should be where it divides the upper and lower parts in half. What percent have a resting heart rate of no more than 74 BPM? So 74 down, that's 3 of those parts, is 75%. What percent have a resting heart rate between 50 and 59? 50 and 59 is just this little section right here. There's 25% of the data in that section. What percent have a resting heart rate between 66 and 92? That's this part right here. That's 2 of those sections, where that's 50%. Draw the box and whisker plots and give the 5-number summary for each data set. So we have our data there. First step, list them in order. The lowest value, 0, that's our minimum, put a point. The highest value is 11, that's our maximum, put a point. The median is in the middle, which is exactly in the middle of 7 and 7. So of course that's 7, and put your point. Lower quartile is the middle of the bottom half, which is 4. Put your point. We need the upper quartile, which is the middle of the top half, which is 9. Put your point, and then make your box plot. Analyzing box and whisker plots, or just box plots. The box and whisker plot below shows the test scores for a group of 24 students. What is the median score? Median's right there, which is 80. What percent of the students scored between 70 and 85? That's right in there. That's the middle 50%. How many students scored between 45 and 85? That's 3 of those sections, which is 75%, but we want to know how many students, not the percent. So 75% of 24 is 18. If Kate got an 87, how did she do compared to the class? 87 would be about here. She is in the upper 25%, scoring better than at least 75% of her classmates. Fuel efficiency in miles per gallon of a group of cars is shown below. What is the interquartile range? Interquartile range is Q3 minus Q1, so look on your box plot. It's right in between there, which is 30 minus 20, and 10 is the value. What percent of the cars have a fuel efficiency greater than 20? So find your 20 greater than that. That's 3 of those sections. That's 75%. What percent of the cars have a fuel efficiency less than 26? So find 26. It's at our median. That's 2 of the sections. That's 50%. Mr. Athens and Mrs. Gilman gave the same test to their math classes. The scores of each class are shown below. What's the difference in the median score? There's the median for Mr. Athens, 80, for Mrs. Gilman, 75, and the difference between those is 5. Which class had the greater range of scores? So that is how spread out the data is. Mr. Athens is more spread out. The range for Mr. Athens' class is 55. For Mrs. Gilman's class, it's 35. Which class do you feel did better overall, and explain? To me, it looks like Mrs. Gilman's class was better off because all students scored at least a 60. In Mr. Athens' class, only 75% of the students scored at least 60. An outlier is any number more than 1.5 interquartile ranges above the upper quartile, Q3, or more than 1.5 interquartile ranges below the lower quartile, Q1. So it needs to be less than Q1 minus 1.5 IQR, and it needs to be greater than Q3 plus 1.5 IQR. Here's our minimum value, which is 14. Q1, the bottom half of that box, is at 35. Our median's at 38. Q3 is at 45, and our maximum value is at 46. Calculating for outliers, Q1 minus 1.5 IQR is 20. So any data value below 20 is an outlier. Calculating for the upper ones, Q3 plus 1.5 IQR gives us 60. So any data value above 60 would be an outlier. So 14 is an outlier. It's less than 20. In your box plot, when you are creating this, you extend that whisker to the lowest data value that is not an outlier. An outlier is a data entry that's far removed from the other values in the data set. A data set can have one or more outliers causing gaps in the distribution. Conclusions that are drawn from the data set that contain outliers may be flawed. There are two different clusters right there of data values in this dot plot. This one is an outlier because of the gaps. There's a gap between 0 and 50 and a gap between 60 and 80. Find the mean, median, and mode of the sample of students' ages in a college class shown at the right. Which measure of central tendency best describes the typical entry of the data set? And does it appear to have any outliers? The range, 65 minus 20, that's rather large. That is 45. 65 possibly be an outlier. When we put our data into a graphing calculator, we can find our mean to be about 23.8. If you scroll down, you also get the 5-number summary, and our median is 21.5. The mode's the most frequent value, which the calculator will not hand you. You can sort your data, or it's actually in order in that table. 20 appears more than any other data value, so that's our mode. Any outliers? Well, if we do a box plot on our graphing calculator, that 65 is definitely an outlier. So the most typical age in the data set is 20 years old. Here's a histogram of the same data, ages of students in a class. 65, that one outlier, is way off to the right. There is a huge gap between it and the next lower number of 24. Notice the placement of mean, median, and mode. Mode, the most frequent, is 20, and it's farthest to the left. The median is pulled more towards the outlier. but not as much as the mean. The mean is influenced more by outliers and unusual data values. Your assignment is a box plot analysis worksheet for fall 2020, and it is posted in Google Classroom.